A very good day, everyone. We are from Group 6 BTC3003. My name is Vinitha A Rajendran. My metric number is 207396. My group mates are Norsyifaa Imanina binti Nazri, matrix number 207560. Nur Sofea binti Mohd Akhwan, matrix number 207609. In this video, we are going to present you a unique instrument which is nuclear magnetic resonance and an R spectroscopy. Have anyone heard about it before? Yes, no? So let us share our knowledge about this instrument. Before that, our contents of discussion will be introduction, the function, principal components of the instrument, example of models that are currently in the market, special features, and also application. So, what is nuclear magnetic resonance spectroscopy? It is a study of molecules by recording the interaction of radio frequency electromagnetic radiations with the nuclei of molecules placed in a strong magnetic field. The function of NMR spectroscopy is to allow the direct observation of chemical reactions. Secondly, it is also used for determining the molecular structure at the atomic level of a sample. It determines both pure compounds and mixture as either solids or liquids. Besides, it also used for determining the phase changes, conformational and configurational alterations, solubility and diffusion potential. For instance, PTN, post-transitional modification, alters proteins' conformation and function in a ways that are not entirely understood at the molecular level. So, NMR spectroscopy helps to map the conformational changes and also detects modification at a site-specific level. NMR is the most sensitive and powerful tool for the determination of polymer structures and the presence of functional groups in a polymer chain.
Thank you, Vinitha. Now I will explain about the instrumentation of nuclear magnetic resonance. Let's look at the diagram in the slide, which shown the schematic diagram of NMR setup. Actually, there are many components involved. However, we can focusing on the experimental apparatus when performing sample with NMR consists of four major systems, which are electromagnetic system, transmitting circuit, receiving circuit, and a computer which perform analysis on the received signal. So let's look at a detailed component of NMR that will be further explained later. It may consist of magnetic coil, probe unit, a frequency generator, sweep generator, radio frequency receiver, also known as detector, and recorder. The instrument name itself did mention about magnetic. So of course, the major component of NMR is magnet. So magnet is used to produce the magnetic field, which determine the frequency of any nucleus. There are two factors to design magnet to give you a good result. Firstly, we can say that the stronger magnetic field, the better line of separation of chemical shifted nucleus on the frequency scale. The meaning of chemical shifter can be defined as difference between resonant frequency of spinning proton and the signal of reference molecule. So, large number of frequency on machine have large magnetic field, give a signal that are less likely to be overlapping, which could in increasing resolution to determine the molecular structure. Is it recommended to use at least 22,000 Gausses of magnet strength? Next, the magnet used must be able to give stable and homogeneous magnetic field, and the direction of magnetic field should be constant, so the sample not producing a broad signal because of the different frequency produced by a nucleus. Next is magnetic coil, which also known as magnetic field sweep. Actually, it is not easy to vary the magnetic field of a large stable magnet. However, this problem can be overcome by superimposing a small variable magnetic field on the main field by using a pair of Helmholtz coil on the pole face of the magnet. So this coil actually induce a magnetic field that can be varied by varying the current flowing through them. Next is probe unit, which can consider as sensing element of the NMR system, which consists of sample holder, radio frequency generator, and radio frequency receiver. Next, sample holder in NMR function to hold the sample, which can be loaded in 7.5 cm long and 0.3 cm in diameter. So, a good sample holder should be chemically inert, durable, and transparent when exposed to radio wave, and generally glass tube was preferred to use to protect from UV sensitive sample, and also a spinner should be provided in this part of component to spin the tube at several rotation. The reason why we need to do a rotation in order to make the sample in homogeneous magnetic field to get a good result. This is one of the pro tip to get a good result, which the sample must be in liquid or solution to perform NMR to get the high resolution in spectrum. Next, radio frequency generator, which function to generate radio frequency to induce transition in the nucleus of the sample from the ground state to excited state. So in order to generate this frequency, radio frequency oscillator is used. In the slide, they are shown the block diagram, which show the radio frequency source were produced until delivered in the probe to the sample. And there are some of the modification to get a good result. First, the coil of oscillator is wound around the sample container to maximum the radio frequency wave to the sample, and radio frequency coil is installed perpendicular to the applied magnetic field to not change the effect of magnetic field in the process of irradiation. Next component is radio frequency receiver. So when the radio frequency radiation is passed through the magnetic sample, two phenomena, namely absorption and dispersion, may occur. So based on the observation of these phenomena, dispersion or absorption, we will be able to determine the sample resonant frequency of the sample, which give us the data to know your sample molecule structure. Lastly is detector. It should be able to separate absorption from dispersion signal and from radio frequency oscillator. There are two main methods of detection, which is use radio frequency bridge, where use coil for surrounding the sample serve as both transmitter and receiver coil, while another method is double coil method by separate the transmitter and receiver coil. Next, the receiver signal that are amplified is recorded by using a computer device to give you a data. Let's move on to the availability of nuclear magnetic resonance in the market. I have found that one company that manufacture and distribute of NMR, which is from Bruker Corporation from Germany. The model of the nuclear magnetic resonance named as SN 1.2 GHz NMR, which costs 17.8 million for the Bruker SN 1.2 GHz NMR. We can say that as the strength of magnetic field increase, so does the price. So now let's talk about the special features of NMR Bruker model. Firstly, the magnet used to produce magnetic field is using superconducting magnet that can produce large magnetic field from 300 MHz up to world recording breaking at 1.2 GHz. Thus, the sensitivity and resolution result may be obtained without hesitation by using this NMR model. Second, the Essen magnet design features advanced in superconductor technology, able to design smaller magnet coil, so it will result in reduction of physical size and weight. So it can be said here that this NMR Essen line model from Bruker much smaller but yet efficient compared to other NMR instrument from other company. Lastly, the stability of the NMR is improved, which is external disturbance separation (EDS) with up to 99% screening efficiency against external magnetic field. So there will less external magnetic field that will affect the result.
Next, we move on to the basis of NMR spectroscopy. NMR relies on a property of certain atomic nuclei that causes them to absorb, then re-release electromagnetic energy at characteristic frequencies. Shifts in the usual response frequency for a given isotope provide information about their immediate environment, including influences from nearby electrons and magnetic nuclei, making it possible to infer molecular identity, geometry, and many more. Samples are inserted in the center of the magnet and are positioned in NMR probe. So, sample is located at the position of the strongest field and highest homogeneity of the magnet. For high magnetic field superconducting magnets are used. Meanwhile, for lower fields can be generated by permanent or electromagnets. Next, I will tell you guys about the principle of NMR spectroscopy. Firstly, all nuclei are electrically charged and have multiple spins. An external magnetic field is applied and allows energy transfer from base energy to higher energy levels in a single step. The transfer of energy or absorption occurs at a wavelength that coincides with the radio frequency. Radio frequency, which is essential for the absorption of energy, depends on several factors. The absorption radio frequency depends on the chemical environment of the nucleus. It also depends on the typical nuclear location in the magnetic field when the field is not uniform. As the nuclear spin returns to its base position, the emission of energy occurs at the same frequency. This energy transfer matches with a signal, and the signal is detected in a number of ways to process and yield the same in the form of the corresponding nucleus NMR spectrum. Now, we move on to the applications of NMR, which is MRI. Medical practitioners use magnetic resonance imaging (MRI), which is a multi-dimensional NMR imaging technique for diagnostic purpose. It is based on the principle of nuclear magnetic resonance to obtain microscopic chemical and physical information about the molecules. It reveals the detailed images of the internal organs. It produces images based on special variations in the phase and frequency of the radio frequency energy being absorbed and emitted by the image object. Second, NMR can also be used to identify human disorders. It is an invaluable tool for identifying human disorders. The cellular metabolism contains important biomarkers that used to diagnose a wide range of conditions, including tuberculosis, pneumonia, and malaria. NMR spectroscopy allows researchers to identify these biomarkers so that patients can be treated accordingly. It also can be used to identify Parkinson's disease, as well as cardiovascular diseases, and a range of neuropsychiatric disorders such as bipolar, major depression, and autism spectrum disorders. The last application is food quality. NMR techniques are used successfully in various food systems for quality control and research. NMR techniques can be utilized in determining the changes on heat-treated foods. In this technique, change of water distribution and mobility in foods could be determined without damaging to food. In addition, nuclear magnetic resonance spectroscopy is a good method to determine the water holding capacity, intramuscular fat, and total water content of meat. Successfully used another field of NMR spectroscopy is milk and dairy products. Studies were conducted on the water molecules of casein system, serum proteins, and milk powder by NMR technique. Furthermore, NMR applications are used to determine the characteristic of the cheese. Nuclear magnetic resonance is used to monitor the maturation and evaluate the modifications of amino acid and water content in cheeses. That's all from us. Thank you.